Welcome students. Today we are going to discuss about dual slope ADC converters and switch capacitor circuits in our course of analog circuits. Myself, Dr. KIRTI VYAS from RA College of Engineering IT. Let's get started with the dual slope ADC. This slide shows the circuit diagram for dual slope ADC, in which we can see the dual slope ADC is comprising of an integrator which is connected to two inputs VA, which has to be converted to digital format, and VR is the reference which will be utilized to convert the analog signal to the digital signal. Now, as you can see, the output of an integrator is V naught is equals to minus 1 upon RC VI dt. Now, at the right of hand side, you can see the two slopes. One moving from the 0 time instant to end of the t1 time instant with a slope of minus VA upon RC, and second one from t1 time instant to t2 time instant with slope of negative VR, where VR is the reference voltage upon RC value. Now let's discuss about the concept of the dual slope ADC, how it is capable of converting the analog signal into the digital signal. First of all, we turn the switch towards the VA, that is the voltage, analog voltage, which has to be converted into the digital signal. Then the analog signal is integrated by the op-amp till the t1 time, and the slope of the integrator is minus VA upon RC value. The second instant after t1 time, we put the switch to the VR, that is reference voltage, and again integrate. Obviously the VR is in opposite sign of that of VA. Again we integrate, and the second slope comes with the time instant from t1 to t2, and t2, end of t2 is the time where the slope approaches the zero value. In a dual slope ADC, a counter output which is proportional to T2 provides the desired digital output, and hence the analog signal is converted to digital format. This is the circuit diagram of the dual slope ADC. Here we can see a SPDT switch with VA and VR voltage levels as inputs, the integrator, then the comparator with a clock which is fed to an n-bit counter. Here the task of an n-bit counter is to produce an output which is digital version of the applied analog VA voltage. The next topic is switch capacitor. The switch capacitor is basically a configuration which is mostly used in ICs, and in this slide you can see the working of the switch is governed by two MOSFETs M1 and M2, which are applied different clocks phi and phi dash to indicate that if one of the MOSFET is in on condition, the other MOSFET is in off condition. Whenever the voltage, there exists a channel inside the MOSFET, the resistance of the MOSFET will be low. That will indicate the on state of the MOSFET, and whenever there is no presence of the channel in the MOSFET, it will indicate the off state of the MOSFET, or the high input impedance will give a off state of the MOSFET. Applying the signal V1 at the input port and V2 at the output port and applying the voltage for and doing the analysis for a period of one switch cycle, that is T1 plus T2 equals to T, we see that the switching frequency f clock is equals to 1 by T, and we assume that V1 is greater than V2 and the S1 is closed and S2 is open. Then we see that C will get charged to V1 in time T1, and when S1 is open and S2 is closed, C1 discharges to V2. The cycle is repeated at same time duration T, small t, which is equals to T1 plus T2. Hence, we can derive or write the equation of the charge inside the capacitor, and accordingly we can write out the equation of the current, and we can have the relationship the current will be equals to C1 f clock V1 minus V2. The equivalent circuit for such kind of switch capacitor is shown in the diagram, where you can have two voltage levels V1 and V2 at the two ports, and the capacitor effect and the MOSFET effect represented by the resistance R1. The switch capacitor can be applied to the integrator, and here you can see the switch capacitor with the MOSFET M1 and M2 are applied to an integrator circuit, which is going to give a cutoff frequency of 1 upon 2 pi R1 into C2. Also, the switch capacitor can be used to implement a filter. Here you can see the switch capacitor with switching indicated by S1 and S2 switches, and the capacitance value by C1 and C2 switches, and hence this particular switch will here work as a summer and also the first order switch capacitor filter. This is about the working of the switch capacitor in different applications. We can also have an integrator summer, which is indicated in the slide, and we can have a FV output due to the presence of two voltage level V1 and V2. The references for these slides are taken from these particular references. Thank you.